Hello and welcome to fresponse.com. Today we're going to talk about fresponse universal, specifically leveraging it under a Linux examiner platform. You'll see we've got a sans sift kit here. We've chosen to use that platform because it's got a lot of tools and additional incident response technologies installed on it. All right, so the first thing we need to do is we need to install the fresponse universal packages. We've gone ahead and taken them off our appliance. This is key. You're not going to find them out on the web. You're going to find them on the appliance itself. This way we make sure that the appliance and the examiner tools stay in sync. Alright, once we've installed the appliance software, the examiner tools, we're going to do a couple of post setup commands. Essentially what we're going to do is we're going to make sure that we own our user account owns the varlib fresponse folder and has the appropriate execute permissions on its contents. This lets us hold information about subjects on the appliance, caching details, etc. Now, fresponse for universal, the examiner tools use Fuse. Fuse is a separate package that allows us to mount these live device targets. So we're going to go into the Fuse file and alter it to allow other users to mount Fuse devices. This just means we don't have to be root to mount those devices. Alright, so most of the work we're going to do today is going to be using the fsexa command and the fsuniv command. So we'll start with fsexa. First thing we're going to do is use that examiner tool to add a user. In this case, you can see our username there and, of course, the appliance. Then it's going to prompt us for the password and add that appliance into our configuration. Now, we're going to run the same command, but this time using start to open a connection to the appliance and pump it into the background. So what that's essentially done is we've set up a user account, we've logged into the appliance, and there you can see a little details about the appliance and the date of its license expiration. And doing an fsexa status is going to give us that details in sort of a comma delineated, more parsable manner. Alright, so now that we've used fsexa to kind of start up our connection, let's use fsuniv to look at what's on our appliance. So issuing the list command is going to give us the appliance, the subject name, the targets, the types, the size, block size, count, etc. So this is a lot of information about a specific disk or subject on the universal appliance currently. So we're going to look at three different targets. The first target we're going to look at is called the discovery share. The discovery share is a file and folder representation, sort of like a share, of the data on the remote machine in sort of a file system neutral manner. This gives us the ability to look at a machine maybe if we didn't have a file system tools or the ability to mount a specific file system on our examiner platform. Now, of course, this is Linux. We have the ability to mount something like NTFS, but just for the sake of argument, we're going to go ahead and mount this discovery share and do an ls-l in that folder. Mounting the discovery share is going to create a folder underneath the subject name with the target name, and that folder will contain the file and folder content read-only of the remote machine, in this case the C drive of that remote machine. And here you can see that data there. You see all the original dates and times are unchanged, things like the $MFT, etc. Now, we're also going to look at mounting a physical device. In this case, we're going to look at disk-0. That disk-0 is we're going to mount it to our machine, and when we mount that device, it's going to appear as a raw file. Again, a lot of things in fresponse under Linux appear as these raw live files. So mounting that device is going to give us if you would imagine, almost a live view of a DD copy of the remote disk. Now that's fine. We could leverage that with different scripts, different tools, or we can also mount it as a physical device on our machine. So now that we've got it attached, we've attached disk0-30720 from subject M Shannon A73B23, we're going to go ahead and run something called LO setup. Now that's going to create a loopback device, in this case dev loop 0. What that's doing is it's going to translate read requests against that device to read requests against our flat file. And here you can see dev loop 0 there. Now why would we do this? Well, we're doing this because certain forensic tools really prefer to read from a physical device. For instance, let's go ahead and run MMLS from sleuthkit and look at the partition table on that device. Here we can see unallocated, primary table, NTFS, etc. So it gives us some flexibility by using the IOS or LO setup, the loopback device. It gives us some flexibility to be able to leverage different tools. And again, using things like SleuthKit is really outside the scope of this video, but you'll find them installed in the CIF kit, and they're available on the internet to install on your own Linux machine. All right, that's of course FLS, which is giving us a listing of the files and folders on the machine. All right, so the last thing we're going to do is we're going to mount a memory share. The memory share is kind of a unique entity. It's a lot like the discovery share in that it is a file and folder, but in this case it has only one file. And that singular file is the remote machine's physical memory, of course delivered as a live file. So just like before, you think of it as like a DD image, except it's not a point in time. It's a live file. Reading from that file is like reading from the physical memory of the remote machine. Now, what does this mean? This means we can use tools like Volatility, which is an excellent tool for performing memory analysis live against that mounted file. So the first thing we want to do when we use Volatility is make sure we have the right profile. Volatility needs to know what the remote machine's OS is so that it uses the correct structures to analyze that memory. So we're going to look at the profiles that are available. We know that the remote machine is an older WinXP SP3 x86 machine. So we've looked at our profiles, we've decided which one we want to use. We're going to use that profile along with the memory, the raw memory file that we have attached, and then we're going to run a singular command from Volatility. In this case, we're going to use the pslist command, which is going to give us a listing of the active processes on the machine. And there you see a list of the running processes on the remote machine in real time. So as you can imagine, this gives us a whole lot of flexibility. It gives us the ability to use the product in a number of different ways to access all of the different F-response specific targets. And then you can also see how you can leverage the different tools that are available in something like a SIFT kit, or just generally speaking under Linux, to expand the capability. All right, so detaching from individual devices is pretty straightforward. We're going to go back to LO setup, and we're going to detach our loopback device, because we want to make sure that the operating system has let go of our live file. And then we're going to use the univ command to unmount the individual devices that we've attached from that appliance. So in this case, we would detach the share device, and then we would detach the physical disk as well as the memory share. So we would detach each one in sequence. All right, very straightforward, simple to use. Once we've detached each one of the devices, we'll go through the process of detaching ourselves from the appliance. So we'll go back to that fsexit command and stop our connection to the appliance. And then we can also remove the appliance from the system by using remove and the appliance network address. All right, so that gives you a good summary of how to use F-Response Universal under Linux as an examiner. If you have any questions, please don't hesitate to contact us. We're available on the web at www.f-response.com, or you can send us an email at support@f-response.com. Thanks a lot, and have a great day.